because it has a lot of open source libraries which are very easily available, especially for deep learning applications. So I believe you have deep learning scheduled in your workshop. So you will be making use of TensorFlow, which is made by Google. So this TensorFlow API is built on Python. So as you go towards the advanced applications, lots of APIs and standard libraries are available for Python. So that's why Python is very preferable for engineering research. So that is why we are using Python, and it is free and open source. Right? Whereas MATLAB is proprietary and very costly. So why not use free and open source software? So that's one thing. Secondly, Python is a interpretable language, high-level interpreted language, in the sense that you don't have to write small things. For example, if you compare Python and C program, so if you have to just read an image, in C you have to write at least 5 to 10 lines to just read an image, whereas in Python it's just one line. So that's the power. So it's a high-level interpreted language, so we are going to make use of it. Now there are two versions of Python available, Python 2.7, Python 3.5. Today we are going to use Python 2.7. There is not much difference between the two versions. Some syntactical differences are there. Today we are going to use 2.7, Python 2.7. So the first question is how to install Python and the associated libraries. So there is one software known as Anaconda, which is already installed on your machines over here. So Anaconda is a distribution for Python. It does not install only Python but also the associated libraries like Numpy, SciPy, Pandas, Matplotlib, even everything that we are going to use. Everything is installed in one shot. You don't have to separately install all of this. Okay? Everything gets installed just by using Anaconda. If you just type Anaconda Python installation on Google, the first link you will get, and you can easily find out the Anaconda installer. You will get 32-bit as well as 64-bit, both options are available. Now, how to run Python? Okay, so I told you how to install Python. Installing Python is using Anaconda. Now, how to execute the Python programs? So let's say I have written a Python program and I want to execute it. There are various ways of executing it. By default, when you install Anaconda, there is a IDLE. That's the editor for Python where you can write Python programs, compile and execute. That is one way of doing it. That's like the old school way of doing it. There is also new GUIs available such as PyCharm, Spider and many other things. Today we are going to use something known as Jupyter Notebooks. Jupyter. Okay. So why Jupyter Notebook? Because I will show you that it's a very interactive way of doing the programming. Normally when we write programs, we have only the program and we cannot write the documentation associated with it. Let's say I am implementing a program known as gradient descent. I want to do optimization, so I want to implement gradient descent. Now in order to explain gradient descent to somebody, I need to write the theory, I need to have the equations corresponding to it, and then I have the code corresponding to it. So this is not possible in a standard GUI or a standard editor. But with notebooks it is possible because you can have documentation, you can have images, you can have equations, you can have audio, video, and the code, and along with the output of the code, everything in one place. So that is what we are going to use today, Jupyter Notebooks. So let me begin with helping you to open that Jupyter Notebook. Can you just tell me where is that folder saved, in which drive? On desktop. On desktop. VIVA folder. So those Python notebook files are where? Okay. So what you can do is, so on the address bar of your Explorer, just copy that path. Open the Explorer from your folder where that Python notebook files are there. Address bar, just copy the address of that folder. And then what we'll do is, we'll open CMD, open the DOS command prompt. Open the DOS command prompt. and type cd space, just paste that address. So you should do on the command prompt cd space, just paste the address of that folder and press enter. Everybody still here? Yes. Now on this part type this Jupyter space notebook, Jupyter space notebook, and press enter. On the command prompt type Jupyter space notebook. Note the spelling of Jupyter, Jupyter. Okay, and press enter.
Not recognized.
Once you press Jupyter Notebook, a browser should open up and you should see something like this. If it is not recognized, then it is probably not installed here. Are you getting this? Browser, are you getting this? Not getting. Not recognized, that is not installed. Yeah, you should get this browser. You're ready to read. All of you can see this file? Basically stands for numerical Python. All the numerical methods are implemented separately in Numpy. SciPy stands for scientific Python. All the engineering related techniques are implemented in SciPy. Then we have pandas. So if you have used a C program or a Java program, you know arrays. Arrays are two-dimensional. So pandas are multi-dimensional, more advanced than arrays. So we'll see the functionality of pandas. Then next we'll look at pickle, which is for saving and loading the Python objects on your hard drive. And the last one is matplotlib, which is for visualizing the data. How do I visualize my data, like scatter plot or a histogram plot? So all this we are going to look in this first session. So we scroll down. So here, in introducing Jupyter, there is a concept known as Markdown. So Jupyter, as you can see, you are working now in a browser. You are not using any editor. Okay, you are using a browser. Everything, what you will be doing, all programs will be done in a browser. Here you can write theory, equations, load the images, write your code, execute the code, everything. Everything we are going to do in this browser. So what is this Markdown? Markdown means writing the theory part of your associated code. It's like a documentation of your code. So that is known as Markdown. So if you observe over here, this is what we have written over here. And you can see the equations are also displayed over here. If you can observe, this is an italic style, this is a bold style, there is a hyperlink over here. So I'm just showing you all these possibilities that are there in the Jupyter notebook. Okay. Now, how to display image in Jupyter. So in this cell, just click on this cell over here in your notebook. Click on this cell. So something like this you see. Just click on that cell and press Shift Enter. Click on that cell and press Shift Enter. See on this cell, click anywhere inside this cell and press Shift Enter. You should see this image. All of you can see the image? Yes. So Shift Enter means we are executing the code written in that cell. So in that cell, a code is written. How to execute the code? There are two ways of executing the code. Please pay attention. There are two ways of executing the code. One is Shift Enter and the other is Control Enter. Shift Enter means the code will get executed and the focus remains on the current cell only. Control Enter means the code will get executed and the focus will move on to the next cell, the cell below it. Okay. So by doing Shift Enter, the focus is still here, right? You can see this image. So in this image, I am just showing you the popularity of the Python language. You can easily see the comparison of Python language with all other languages. And this data is obtained from a website known as Kaggle. You see here. Now Kaggle, K-E-G-G-L-E, is a popular website for aspiring data scientists where they hold competitions for machine learning people all around the world. So they throw up a challenge every week and they will give you the data and use your machine learning algorithm, and whoever gets the best performance, best accuracy wins some prize. So that is the Kaggle website. So from the Kaggle website they are showing that the most widely used language is Python. Okay, so what did we do to display the image over here? So from IPython, so IPython is the class inbuilt in Python. IPython stands for interactive Python. From IPython.display, so IPython.display is a class in Python which will have multiple components. From there we are only importing the image class over there, and the image of in quotes, just specify the path of that image. So if you open the Explorer, in that folder that you have a folder known as image. Inside that image folder, this image is there. So that image we are displaying over here. So simply what you do, image of, in quotes, specify the path of that file. And then we can additionally specify what is the width. If you decrease the width, the size will be small. If you increase the width, the size will be bigger. So we can easily control that. So this is displaying images in Jupyter. Next, let us come down. Is the internet connection available here? Yes. Next, we will see how to display video in Jupyter. Okay. Now come to this cell, and what you have to do to execute this? Shift Enter. Please click on this cell and press Shift Enter. You should see a YouTube video which you can click and play also. So Python directly supports a YouTube video class. Again from IPython display, import YouTube video. And what is this? This is the unique identifier of the video on YouTube server. So homework for you, you can look at this video later on. It's a very nice video. It's a TED talk given by somebody on the beauty of linear algebra. You can have a look at that later. So displaying video in Jupyter is so simple. You have to just import YouTube video and the corresponding ID. Let us come down. Mathematics in Jupyter. Mathematics in Jupyter. Just click on this cell and press Shift Enter. You should see the corresponding equations very nicely formatted. All of you can see the equations. Now how are the equations written here? The equations here are written using LaTeX, a LaTeX language which is used for writing the equations. We are not going to do LaTeX today, but this is just to show you that equations can be very nicely formatted using the LaTeX. If you are familiar with LaTeX, then I'm just writing the equation array over here, and slash nabla is this operator, slash times is this, slash vector, slash volt b is this, and so on. So using LaTeX, I can very nicely write all the equations over here. Okay, let us come down. So we have looked at math, and finally we'll also look at how to load the audio signal in Jupyter. So again come to this cell and press Shift Enter. I'm just explaining. Just press Control Shift Enter here. So you should see an audio signal below that, which you can play as well as you can download. So basically what we have done here, we have created a synthetic audio signal over here. Let me just explain to you what is written over here. Import Numpy as NP. So basically in Python we are just going to import multiple libraries. So Numpy is a library which we are going to work very soon. So Numpy is a library, and what we are doing, import Numpy. Numpy is a full library. Instead of writing Numpy everywhere, we are creating an alias for it. So import Numpy as NP. So henceforth we need to write only NP. No need to write Numpy every time. That is the meaning of import Numpy as NP. Henceforth just write NP something. From IPython display import the audio class. So far we have imported image class, video class, the audio class. Okay, here I am defining two frequencies, the sampling rate, the duration, time equal to NP dot lean space. If you have worked with MATLAB or Scilab, you understand what is lean space. So here I want 0 to 3 rate into L. So basically 8000 into 3, that many samples I want between 0 to 3. So basically 24,000 samples I want between 0 to 3 seconds. That's what it is saying. And I am creating a synthetic audio signal over here. The first signal is sine wave with 2 pi f1t plus 2 pi f2t. How did I write the sine? Np dot sine. So sine function is available in the numerical Python. Np dot sine of 2 into pi is np dot pi into f1 into this sine here plus 2 pi f2t. So I just treated a synthetic audio signal, and then audio class data equal to this signal and rate equal to this sampling rate. So you can play that signal and you can download that signal. So we have seen that besides the theory, we can also have mathematics, image, audio, video, everything along with your code. So it's a very fun way of doing programming. Okay, let us go down. Doing some theory that I will give you. These are all the packages that we are going to read. So we have seen Numpy, then SciPy. SciPy, as I told you, that is for engineering. We are going to look at one optimization. Whatever is in course will be printed as it is. And notice that this X is not in the course. So the corresponding value will be displayed. So this is the important thing. In print, whatever is in course is a string. It will be displayed as it is inside the course. And this variable without the course, the corresponding value will be displayed. Can you try this one also? I defined another variable here. So notice that this will be printed as it is, but this is the value. This is printed as it is, but this is the value. Just do shift enter from this, you should get the output. Okay? Okay, so that is all trivial stuff. Now let us move on to the interesting stuff here. Python list. So this is a new data structure available in Python, something known as a list. So let us see how list works. So here, x equal to list of range 10. So let us understand what is this. Range 10 means I want 10 numbers starting from 0. Python begins at index 0. So that is something you have to remember. Python begins at index 0, not 1. MATLAB begins at 1. C begins at 0. Python also begins at 0. Okay, so beginning index is 0. When we specify range of 10, I want 10 numbers starting from 0. So 0 to what is the last number? 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So range of 10 will be that 0 to 9. And list means that will be displayed in a square bracket. It's like a one-dimensional vector. One-dimensional array of 10 numbers from 0 to 9. So that will be x. Okay, just execute this cell, shift enter, print x. So you will be seeing this 0 to 9. So this is called a list. Now remember, you can just make a note. List means square bracket. Square bracket matlab it's a list. It is an array. Because the type of brackets will decide the data structure, which we are going to see soon. So square bracket means this is a list or an array. Now second thing, x dot reverse. Now see how we are doing this. X is a list object in Python. X is not simply a variable now. It is a object in Python having the type list. It is an array. So we can apply the functionality on it. X dot. I am applying a function reverse. Reverse is a function over here. Just by doing this, you can see that the entire thing is reversed. Whereas if you do the same thing in C, you have to write a for loop. इतना program लिखना पड़ेगा आपको. But this is one line in Python because it's a high level language. All of you getting this output? So reverse. Then I want to add one more element. So append. Add one more element. So append 5. You can see this 5 got appended towards the end. Now I want to sort the array. X dot sort. You can see that the array is nicely sorted. So one line things in Python. Okay. So what we have created so far is a Python list. Python list. Let us proceed further. Please keep on pressing shift enter. Now inside this range there are two numbers now. In the first one we had only range of 10. Now we have range of 5, 10. Start from 5 till 10 but excluding 10. So this is very important over here. Pay attention. Starting number is 5. Last is 10 but excluding 10. Why? Because Python begins from 0. That is the simple reason. So 5, 6, 7, 8, 9. 5 numbers I want. 10 minus 5. 5 numbers I want. 5, 6, 7, 8, 9. Not 10 because indexing begins at 0. So this you have to remember throughout the session. Okay. So start number, comma stop number. Start number, comma stop number but excluding the stop number. If you come down 0, 10, 2. So what is happening here? Start number, stop number, step size. By how much you want to increment? अभी तक क्या था? By default increment was step size of 1.
Here we haven't written print. So without the print command,
I have just written X.
Yeah.
So it will display. Display the
print
variable.
command is not the print bracket.
Without that it is also it will okay. You just write the variable and it will print. 0, 10, 2. Start number, stop number and the step size. So 0, 2, 4, 6, 8. Remember because excluding 10. 10 is excluded. Okay. Now here 10, 0, minus 1. What is happening here? Start number, stop number and go back. Minus 1 means decrement by 1. Decrement by 1. So starting from 10. But what is the last number? 1. It will not go till 0 because that is excluded, that index is excluded. उसके पहले तक. So 10, 0, -1. You can go forward, you can go backward, you can specify the step size. So basically range function takes 3 arguments. What are those 3 arguments? Start number, stop number, and the step size. Step size either you can go forward or backward. So all this is still a list. We have created a list. Now we will do something known as slicing the list. Okay, so we have seen this start number, stop number, step size. Now the syntax. In square bracket is to specify colon stop. In square bracket is to specify colon stop. So colon means start from the beginning till this number but excluding this number. Start colon means start from this starting index till the very end, because here I am not specified till where. Colon means anything. -1 means suppose going back. So let us now execute this cell. Let us execute this cell. We will try to understand what is written here. So we have created a numbers list. In this numbers list, 5 numbers are there. Print numbers. These 5 numbers are there. Now, pay attention here. Print numbers of 0:3. Remember the Python indexing. This is index 0, index 1, index 2, index 3, index 4. Okay. So here I am saying numbers of 0:3. So 0, 1, 2, 3. So, sorry. 0 to 3. Start to stop, but excluding the stop. So 0, 1, 2. Remember start, stop. Starting from the start number, but excluding the stop index. So 0, 1, 2. 0:3 मतलब 0, 1, 2. I want 3 numbers starting from 0. So 0, 1, 2. 4, 7, 24. Next, print numbers of -1. -1 start from the very end towards the right. 0 means start from the number at the left. -1 मतलब इधर से उल्टा है. -1 मतलब number at the right. So numbers of -1 is 2. Numbers of -2 will be इधर से पीछे जाएगा. 11. This is number of -1. This is index -2. What is this index from here? -3, -4, -5. Okay. Now this numbers of 3 colon. What is this? Starting from location 3 till the very end. So 0, 1, 2, 3, 4. So 11 and 2. Starting from location 3 till the very end. 3 colon. So 11 and 2. Please understand all this. This is very important for the next session for doing machine learning. These are all the basics required. Numbers colon -1. Colon -1 means, is there a start number specified here? No. So you have to begin from the very beginning towards the left. Stop index is -1. But excluding -1. So 0, 1, 2, 3. Because this is -1. So 4, 7, 24, 11 will come. Please make sure you understand this properly. Colon -1. Start from the beginning. Stop index is -1 but excluding -1. Colon 4 is same as this. Colon 4 is same as this. Why? Because location 4 here is same as location -1. 0, 1, 2, 3, 4. -1, -2, -3, -4, -. All of you getting this? So this So this syntax is important to remember. Start, stop and step. Okay. Now the basic control structures for loop, while loop, if. How to define. You can see if, elif and else are keywords, so they have a different color. Next look at while. Again this should be very simple. So I am defining I equal to 0. While I less than 5 colon. Anything after the indentation is a part of while. There is no end over here. So I am printing I and then incrementing I by 1. So initially I equal to 0, print 0. I equal to 1. I less than 5. Print 1, 2, 3, 4. So go till 4. Notice that there is no end over here. Anything after the indentation is a part of Y, and this is followed by a polar. Okay, so we have seen for, if and while. These are the primary control structures. Now, of course, we can use the control structures, but there is something in Python known as comprehension. Now, this is a new thing in Python which we are going to learn, list comprehension. So, just execute this cell. I'll just explain to you what it is this. You should get this output. Just execute this cell. Are you getting the output? 15, 18, 21? Okay, let us try to understand what is happening here. Now, let us understand. T equal to, I am opening and closing a square bracket. So, what data structure is this? It is a list. T is a list because I am writing everything inside a square bracket. So, T is a list. What numbers I want to put in that list? X multiplied by 3. So, I need to define what is X. So, here I am writing for X in another list. This is also square bracket. This is another list. 5, 6, 7. 5, 6, 7 matlab this is a list. So for X in this, which means, so first time X will be 5. Then do X into 3. The next time X will be 6. Do X into 3. Next time X will be 7. Do X into 3. So in one line, I have written a list within a list. List comprehension. From one list I am making another list. This is known as list comprehension. Is it clear? From one list making another list. Okay, now there are lots of functions inbuilt in Python. Suppose I don't know the meaning of a particular function. So how do I access help? Help किधर से मिलेगा? MATLAB में तो direct help होता है. How do I access help? So any function you want the help, question mark followed by the function name. So just try press shift enter here. Question mark complex. You see this on that cell? Press shift enter. On the bottom you will see a help for that complex function. Question mark complex है ना? Just press shift enter.
It's not here.
नहीं आ रहा?
Complex है.
अच्छा नहीं है उधर. Okay. So what we can do is wait. So what we will do is one second. Yeah. So in this cell, you have this cell, right? So put the focus on this cell, and then we will do insert. देखो ऊपर insert cell below. Insert cell below. So new cell will be inserted, and then you type this question mark complex. This is how you can insert new cells and write the code. One more thing you should observe when you inserted the cell, by default, code. When you click on this drop down, see what options are available. Click on that drop down. You have code, markdown, draw and deconvert, heading. Okay, so basically this is my heading. This is my code. Okay, so theory होगा that will be marked down. These are the different ways cells can be partitioned. Okay, so you write here question mark complex and you execute that. So you should see a dot string below. और नीचे help दिखेगा like this. You should see a help for that function. So can you read that help? Given two numbers, it will a comma b, it will return a plus jb, complex number. Okay. Given two numbers, real and imaginary. Okay. Now, let us focus over here. Now you are at this cell. Now don't press shift enter. I want you to think output क्या आ सकता है इसका. Before you press shift enter and look at the output, can you please think for a while? इसका output क्या आ सकता है? Think carefully. This is the list comprehension. What is happening? Z equal to I am making a list complex x comma y. So x and y I have to define. X and y are defined in this column. X in range 0 for 1. What is the meaning of 0 for 1 here? Start number, drop number excluding 4 and step of 1. मतलब x can take the values 0, 1, 2, 3. ठीक है. Y का 4, 3, 2, 1. 4, 3, 2, 1. Excluding 0.
0, 1, 2, right? Excluding
Which
0
one?
to 4.
This one. This one. 0, 1, 2, 3. X is 0, 1, 2, 3. Excluding 4. X is 0, 1, 2, 3. Y is 4, 3, 2, 1. So we have defined X ka range, Y ka range. If X greater than Y. So I want to do this operation only if X is greater than Y. Because Z will contain complex numbers of X plus JY only if X is greater than Y. So can you take a pen and notebook and think what will be the values of Z before you execute this? What will be the values of Z? So X is 0, 1, 2, 3 and Y is 4, 3, 2, 1 and we have X greater than Y. So this is not possible, this is not possible, this is possible with this. So we will get 2 plus JY. Then this is possible with 3, 2 and 1. So 3 plus J2 and 3 plus J1. These are the only numbers you should get. Can you press shift enter? Should get that out. Are you getting the output? So this is the power of Python. Using a comprehensive list, you can define your conditions and control structure and easily you can return a list as per the given conditions. Okay, clear? List is done. Now we are going to the second type of data structure called as dictionary. Second type of data structure known as dictionary. See how a dictionary is written. Starting with a curly bracket, ending with a curly bracket. That means it is a dictionary. If it is a start and stop with square bracket, what it is? List, jo abhi tak kiya humne. But if it begins and ends with a curly bracket, then it is a dictionary. Dictionary basically contains two things, a key and a value. The location and the value at that location. Dictionary contains two components, the index or the location, also known as the key, and the value at that location. So how to write the location? This is the key, written in quotes always. The key is always written in quotes. Location is always written in quotes. The technical term for this location is key, K-E-Y. This is a key in quotes, colon, the value at that key. So at key A, my value is 1. So this is the first dictionary element, comma. Second dictionary element, key B, what is the value of this key? 2. Second dictionary element, comma. Third dictionary element. So this I am defining a dictionary, and if I just type D here and execute, you should get this dictionary output. How have we defined the dictionary? Starting and ending with a curly bracket. A dictionary consists of two things, key and the value of that key. Okay, here the order is not important. You have to just specify the location or the key, colon, the value of that key, and the key is always in quotes. If I want to access the value of some key, notice that this is a square bracket because I am accessing a particular element B of this key. It will return the value of this key. B is what? The dictionary element, the dictionary structure. D of this key will give me the value of that key. Suppose I want to know what are the keys available in this dictionary. So D dot keys function. Give me a list of D dot keys. This is the list of all the keys. Notice that it is not sorted. If you want, so dictionary is clear. Dictionary means starting and ending with curly bracket, and it has two things, the key and value. Let us look at dictionary comprehension now. Just like we had list comprehension, we will do dictionary comprehension. Since I am writing on the dictionary, so open it was with curly bracket. If I do a square bracket here, to list हो जाएगा. Okay. Now A equal to curly bracket. For dictionary, I want two things: key and value. Key colon value. Key colon value. So here I am defining n colon n into n. मतलब ये location रहेगा. key रहेगा colon n into n, the value of that key. So I have to define n, for n in range 7. अब ये range 7 मतलब क्या? 0 to 6, and then I print a. Even if I write a here, that's okay. Key value, and so on. So key can be a number also, not necessarily a string. Key can be a number also over here. So key and the corresponding value. This is a dictionary comprehension. So if you notice here, now A is a dictionary with corresponding keys and values. Now this over here is similar to this, but slightly modified here. I have just added a if condition here. What is this condition? If n percentage 2, मतलब क्या इसका? If n percentage 2 means if it is divisible by 2, only then you do this operation, otherwise not. This is implied over here. If n percentage 2 equal to 1. Look, if this condition is true, only then execute this. Otherwise, if false होगा तो don't execute this. So that is the meaning of this. So n percentage 2. Okay. So I want to do odd squares over here. So 0, 2, 4, 6 will not come because the remainder is 0. n percentage 2 का remainder find करना, right? n slash 2 will be the quotient. n percentage 2 is the remainder. So 0, 2, 4, 6 will not come because the remainder is 0. So if 0 हो जाएगा. But 1, 3, 5, the remainder with 2 is 1. So only those numbers will come. So these are, I am printing odd squares over here. Percentage मतलब क्या? Remainder. Slash मतलब quotient. All of you getting the output till here? Question? n percentage 2. No, execute this part only if this condition is true. Only if this condition is satisfied, then I put the key and value. Otherwise not. Is the remainder? No, if this is 1, only then you do this. Otherwise not.
Sir, I can write equal to 1 as well.
How? That is implied.
Yeah.
Numbers 1, 3, 5. What is 3 percentage 2? What is the remainder? 1. So then that condition will be satisfied and this operation will happen. 4 percentage 2 is 0. So this will not happen. Okay? Okay, so we have looked at two data structures, list and dictionary. There are other data structures also, but that is not of concern for today. We are not doing advanced Python, we are just doing introductory Python. Okay, so for today's session, this is sufficient to know list and dictionary because we are going to use that. Next, let us see how to define functions. n slash 2. n slash 2 not equal to 0. You have to think of a condition. n percentage 2 equal to 0. n percentage 2 equal to 0. What else? Let us look at functions. How to define a function? How to define a function in Python? So the keyword here is def. Every function in Python begins with def and it is a keyword over here. What is the syntax here? def. Definition of a function. The function name in bracket, function arguments, colon. And then anything which is after the indentation is a part of function. Notice that there is no end over here. Again, no end in this structure. def, function name, function arguments, colon. Anything after the indentation is a part of function. Here I am writing the first argument is name, second argument is loud, and I am defining the default value of this argument. So even if the user does not pass this, by default it will be false. Otherwise the user can also pass true. But if the user has not passed anything, default value is false. ठीक है. So what I am doing, if loud, if है ना, तो colon and then indentation because that's a part of it. Then print I want capital letters, loud है ना, so I want capital letters and name, whatever is the name, name dot upper, तो capital letters में आएगा. Else print normal capital camel case letters. Okay, so this is my function over here. Notice that there is no and over here for any of this, if, else and definition. Anything a part of indentation is a part of the corresponding structure. Now I am calling the function here. The function okay here. This function is defined in here. Now I am calling the function. In the first part, hello of the name is in quotes. Now I am not pass the second argument, but the default is false. So what will be displayed? Hello Jupiter, comma loud equal to true. So this will be this one. Hello Jupiter, everything in capital. So defining a function and calling a function. Simple. Defining a function and calling the function. Just press shift enter over there. Yes? Are you getting the output? True is case sensitive. True and false are keywords in Python. If you write TRUE capital, it won't recognize. It is a keyword. I am seeing here true and false as green color. It is a keyword in Python. Okay, so we are done with the functions. Now before proceeding, let us do a small quick exercise. Write a function called isPrime that takes a positive integer n and determines whether or not it is a prime number. When a first year student से करा था ना, determine whether a number is prime or not. Return n if it is prime and return nothing if it is not. That's the first task. So we have to write a function to check whether a number is prime or not for given a positive integer n. Second task, create a list my primes that contains all the prime numbers less than 100. So we have to use this function and write a list containing all prime numbers less than 100. Okay, so I have written the code here. You can have a look and then write the code quickly. So this is the exercise so that you get the feel of how to write a function. So what I am doing here, defining a function called isPrime and it is taking one input argument, a positive integer n, colon. Notice the indentation. Actually, when you type colon and press enter, it will come here because the compiler understands that you are going to write some control structure. I am defining a count for I in range 2, n because 1 does not make sense here. So I have to start from 2 to n, but excluding n. If it is divisible, count equal to count plus 1. So this thing will keep on going. Notice the indentation is over here. Once the for loop is complete, then I check. If count is 0, मतलब एक भी number नहीं है, divisibility test pass नहीं हुआ, then it is a prime. Prime equal to n and return prime. This is my function. Please write this function quickly. Of course, there are better ways of checking primeness. This is a very trivial way of doing it.
Sir, if n more I is 0 and we want to exit from the loop, we don't want to exit.
So break. There are many ways to do this. I am just doing one trivial way over here. Main idea is to write a function. Practice on writing a function. Once you have defined the function, once the function is defined, next you want to create a list of my primes. So notice that you have to come back here without the indentation. That is important. Otherwise, it will be part of the function. We don't want that. So now I'm creating a list here, my friends. How we have done that using a list comprehension, one line. This is list comprehension. My prime is equal to j for j in the range 1, 100 because I want all prime numbers less than 100, starting from 1 less than 100. Okay, and do this operation only if is prime j. Only if that j is prime, only then include that in the list. Otherwise not. If is prime j, what is our if is prime returning? It will return the number only if it is prime. Otherwise nothing is happening. There is no return value if count equal to not 0. If count not 0, then there is nothing returned. That is how we have written the function here. It will return only if count is 0 because it is a prime number. Only then that number will be returned. So if is prime j, मतलब यहाँ पे non zero हो गया अगर, if non zero हो गया अगर, then execute this for operation. So then when you execute this, you should see all the prime numbers less than 100. So we have used the list comprehension over here. Please check if you are getting the output. Are you getting the output, everybody? Yeah. My friends, equal to na? Equal to. His prime is not. My friends over here. His prime. Yes? इधर हो गया? इधर क्या हुआ? Unexpected indentation. ये picture हो गया? हाँ, एक मिनट ये गड़बड़ हो गया। This if will be below this four. और पीछे। हाँ, और ये लोग को भी इधर। Please note the indentation. Indentation is very important. Python will understand only based on the indentation. If you don't indent properly, your code will not work. Error. Global name prime is not different. Prime 8. Done? Either error? Okay. Okay. वो function return करेगा. If not equal to 0, we then return the price. That is the return of the function. मतलब जो कॉल करेंगे ना उसका रिटर्न वैल्यू उधर आएगा. यहाँ पे एक्सपेरिमेंट इतना ही होता है इक्वल टू एक्सपेरिमेंट. यस ये इधर से है ना इंडेंटेशन is written. Nothing is written.
But we are getting into we should get to that.
2,2 execute नहीं होता.
Excluding the
इधर आया और लोग क्यों करेंगे हाँ ये इंडेंटेशन गड़बड़ है तब बीएफ के नीचे को और इंडेंटेशन के बनी हाँ नहीं आपका बराबर नहीं ऑलरेडी ये देखो one tab indentation is 4 spaces. Okay, so hopefully with this exercise we have got the feel of how Python functions work and how list comprehension works. Let us proceed further. Okay. Now we will do Numpy. Next part is Numpy, which is numerical Python. So Numpy are also arrays, but they are multi-dimensional arrays. Basic definition of Numpy here is it stores the same type of data, and once the size is allocated, it cannot change size. So why to use Numpy? Why use this restriction? Because it is supremely faster than the basic Python operations. It is extremely fast. Okay, I am not going to demonstrate how fast it is, but take my word, it is very, very fast. So how to use Numpy? So Numpy is a library in Python. Does not come by default with Python. If you are installing only Python, you have to install the corresponding Numpy package separately. Here we have installed Anaconda, so everything is installed together. So how to import Numpy? Import Numpy as NP. Why to do as NP? We are creating a alias so that we have to write only NPy, not write Numpy everywhere. So I am just creating x equal to np.zeros of 5. Print x. Please press shift enter along with me. So what we see here? What type of data structure is this? It is a list with 5 elements. All elements are 0. Notice 0 dot. So by default, floating point number. By default, this is a floating 0.0 floating point number. Next, x equal to np.zeros 5,2. So इसका क्या interpretation है? 5 rows 2 columns. 5 rows 2 columns. So you can see here. Notice that this is a double list. First list for all the columns. Then second list for all the rows. First row, second row, third row, fourth row, fifth row. So I have a 2D array over here, 5 rows and 2 columns. Okay. Now look at this. So earlier we had used function range. In Numpy there is a similar function called arange. So np.arange 3,10. This behavior is similar to the range function. So what is this? Start number, stop number, excluding the stop number, and by default step size is 1. So this will be 3, 4, 5, 6, 7, 8, 9. But what if I want to include the last number? Range and arange will not support that. So I have to use linspace. I can use linspace. np.linspace means linearly spaced numbers. You also have option of log space, logarithmically spaced numbers. Linspace means linearly spaced numbers. So what is this? Start number, stop number. How many numbers? 25 numbers between 0 to 1. These are the numbers. Here. Remember the syntax? Start number, stop number, and how many numbers. So in least space, the stop number is also included. So that is the difference between range and least space. Least space means start number, stop number, and how many numbers in that 0 to 1. 25 numbers are there. So if you change this, you can change it 0, 1, 100. Just try that. You will get 100 numbers over here. You can try that. 0, 1, 100. 0, 1, 10. You will get 10 numbers over here. So least space includes the last number. That is important. Next. From math, import pi. So pi is the object in math library. So just one word here. Two ways of defining the import here. So earlier we had import numpy as np, which means every function available in the numpy library is available to you. When you say import numpy, everything that is defined in numpy library is available. But when we do from math import pi, I don't want to load the whole math object in my memory. I just want a particular thing from that object. So from math, just import pi. I don't want everything else. So there are two ways of defining import. Import numpy bola to everything of numpy is get loaded in the memory. If I do import math, everything of math is loaded in the memory. But I want only certain things. So from math import pi. So not all functions of math will get loaded. Only a particular object gets loaded. X equal to np dot linearly spaced numbers. What is this? From minus pi to pi, I want 4 numbers. And then print cos of x. Np dot cos of x. You will get this. Please press shift enter. Check you get the output. What is happening here? Np dot a range pi. मतलब क्या है? What are the numbers here? X 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And what is the meaning of this? X raised to 2. Again over here, what is the meaning of this? 2 raised to x. Just check if you get the output. Okay, done. Let us proceed. Now we look at the functionality of numpy in detail for 2D arrays. Now this image is not there with you. Just have a look here how numpy accesses 2D arrays. So earlier we had seen slicing of list. Start, stop. Now we'll see slicing of arrays. So suppose I have a 3 cross 3 array. And the variable name is ARR. What is the meaning of this? ARR of colon 2, comma 1 colon. इसके पहले जो भी आएगा that is called row. इसके बाद में जो भी आएगा that is called column. Comma के पहले row, comma के बाद column. So I am saying colon 2. Colon 2 मतलब starting से 2 तक but excluding 2. Okay. So 0 and 1. 0th row first row. ये colon 2 का मतलब क्या है? 0th row first row excluding 2. ठीक है. तो first 2 rows आ गए. Comma 1 colon. Starting from column 1 till end. ये column 0, column 1, column 2. So starting from column 1 till end. So this part is this. Make sure you understand this properly. This is a variable name ARR. Suppose it is a 3 cross 3 array. What is this array? Colon 2. Starting from 0 till 2 excluding 2. 0 to first. Comma 1 colon. Starting from first column मतलब ये 0th column. First column till the very end. So this understand how this works. Now here import numpy as np. So I am defining 2 arrays over here. Can you tell me what is the size of D? What is the size of B? How many rows, how many columns? B is how many rows, how many columns? 1 row, 3 columns. D is 1 cross 3. 1 row, 3 columns. What is the size of A? देखिए बाबा, what is the size of A? 4 rows, 3 columns. ठीक है, A is 4 rows, 3 columns, 4 cross 3, and B is 1 cross 3. And what we are doing here, print A, print B, and last में देखो, print A plus B. ये कैसे possible है? What is A 4 cross 3? What is B 1 cross 3? We are trying to add them. The size is not same, but it is possible in Python. देखो output आया क्या देखो? So this is known as broadcasting. So I will show you what has happened here. Output आ गया सबको? So what has actually happened is this. This is the figure representation of what has happened. A is 4 cross 3, B is 1 cross 3. Internally what Python has decided, it is stretching this 0, 1, 2, 0, 1, 2, 0, 1, 2, and then it is adding. So this concept is known as broadcasting, so that it can do the arithmetic operations. Okay, it will automatically do this operation for you. You don't have to explicitly define it. This is broadcasting. Okay, next. In the next cell, just execute this. See, what we have done here is, I hope you are familiar with Gaussian distribution, concept from probability. This is how Gaussian distribution looks like. All of you have heard Gaussian distribution, right? You are familiar with Gaussian distribution? So this is how Gaussian distribution looks like. It is symmetric with respect to this mean mu, and this is the standard deviation sigma. All of you are familiar with Gaussian distribution?
Normal distribution.
Normal distribution. देखा है, right? Yes नहीं आ रहा? Yes or no? Not much. Probability, random variables. So Gaussian distribution or a normal distribution means random variable. Basically, a random variable means we are assigning some real numbers to every outcome of the sample space. Why is that required? Suppose I consider weather as a random variable. Weather can be rainy, windy, cloudy, sunny. Suppose these are the 4 events in this sample space. I want to do some mathematical operations. I cannot do probability. I cannot do rainy multiplied by windy. I cannot do that. I want numbers. That is what a random variable does, assigning real numbers to every outcome of the sample space. That is the meaning of a random variable. The question is how to assign these random variables. So how to assign these real numbers? For that there are various types of distributions. Uniform distribution, exponential distribution, Gaussian distribution, binomial distribution, Poisson distribution. There are so many distributions are there. For example, uniform distribution means every number is equally likely. Every number is equally likely. Whereas Gaussian distribution means something like this. For example, if you want to watch a movie 3 PM to 6 PM in a theater, 3 baje ka show hai. Most of the people will come between 2:55 to 3:05. Most of the people, or let us say between 2:50 to 3:10 PM. Most of the people will arrive in the theater during that time interval. Very few people come very early or come very late. ये है Gaussian distribution. Not every number is equally likely. Most of the numbers are likely towards center. Mean 3 बजे का शो है, 3 बजे के आसपास सब लोग आएंगे. Very rare that people will come here. That is the this is the phenomena which we observe in our daily life. Okay. So Gaussian distribution is very powerful for machine learning, for statistics. Okay. So here we are generating normally distributed numbers or Gaussian distributed numbers. So here we have specified NP dot. So now NP is what? Numpy. Numpy में there is a class random. So all the different random distributions are possible. Random के अंदर normal. I want normal distribution. NP dot random dot normal. So उसके लिए I have to specify 2 things: the mu and sigma. So mu I am specifying this is 100. One more thing here. See in this line, 3 things I am initializing directly. N comma n rows comma n columns equal to 100 comma 10 comma 6. मतलब ये 100 जाएगा n. 10 n rows, 6 n columns. So I don't need to write 3 lines for doing the initialization. Just in 1 line it is possible. Okay, so this n is my mu over here and 50 is the sigma. mu and sigma. And size I want 10 cross 6. Now by default everything will be floating point number, so I am converting into integers as type int. So when I display this, you can see this is our 10 cross 6 integer array, normally distributed numbers, mean is 100 and the standard deviation is 15. Okay? Are you getting the output? This output? Now you can do some statistics over here. Now XS कौन this is our numpy array. Remember XS ऊपर है. XS is the numpy array over here. So I can do some operations over here. XS dot max. So maximum of this array, maximum of the entire array will come here. But if I want maximum along rows or along columns, so I can specify which axis, along which dimension I want.
Can you repeat the previous the random
np.random.normal है ना? So np is a numpy library, उसके अंदर random class है. So multiple distributions are possible, uniform, normal, Poisson, binomial. In that we are accessing normal function. That requires at least two arguments, the mu and sigma. So we are specifying n is 100 and standard deviation is 15. And then I am specifying the size, n rows, comma n columns, which is 10, 6. And by default it will be floating. Just to show here, I am converting into int.
The standard deviation is 15. Why are we getting numbers like?
Very good question. If the standard deviation is 15, so should I get only in this range? Mu plus or minus sigma. Should I get numbers only in this range? No. Because this is just sigma. This is 2 sigma. This is 3 sigma. This is 4 sigma. This is from minus infinity to infinity. This Gaussian distribution goes from minus infinity to infinity. Now this, only the range of first sigma, 67% of the numbers are over here. 2 sigma, around 85% numbers are over here. 3 sigma, around 97% numbers are over here, and so on. You will not get only in this range. That is why maximum is 135. That's a good question. Okay, and you can specify axis to check the maximum along a particular dimension, either along rows or along columns, where x is equal to 0 means along columns, x is equal to 1 means along rows. We are checking the maximum along a particular dimension. Okay, you are getting the output? Let us proceed further. Next, we will look at SciPy. SciPy is the name is Scientific Python. It's a scientific Python library. It's mainly developed for all engineering related applications. Here we are going to look at only one, optimization. This is the concept of optimization. Look at the figure here. Suppose there is a contour where I want to find the global minimum. So on this surface, on a given function, I have to find out the local minima or the global minima, which is what optimization can help us to do. So let us see how it can be implemented here. So import SciPy. So SciPy is a library, scientific Python. So that we are importing as alias SP. So NP and SP are standard used by most of the people. So we'll just stick to that. You can write as your name also. That is also fine. But commonly used is NP and SP. For visualization, we are going to use matplotlib, which we are going to cover in detail in the next 10 minutes. Import matplotlib.pyplot, Python plotting as we are doing. Now I am defining a function here. Can anybody look and tell me what is the function in mathematical terms? F of x equal to x square plus 10 sin x. Barabar? X square plus 10 sin x. That is the function we have defined over here. Then I am defining the range of x minus 10 to 10, step size of 0.1. Then I am going to display this function. So PLT कौन है? Matplotlib का alias है. PLT dot plot x comma y. So x comma f of x and then plt.show. Just execute this, you should get this figure. Execute that, you should get this figure. We are now displaying the function. X-axis पे x है from -10 to 10 in step size of 0.1 and y-axis पे f of x square plus 10 sin x. So here, where is the global minimum? Somewhere over here. Here na global minimum. This is local minimum, this is global minimum. So let us see whether the SciPy optimization library can find that global minimum. Okay? All of you can see this function graph. Okay? Now, this is the code that we want to use. So in SciPy, that is the optimize class. From SciPy.optimize, import minimize. This is the function that we want to use. SciPy library has the optimize class. We don't want to import the whole thing. You can if you want to, but right now I want to use the minimize function. So import this function only. Result equal to minimize. What I want to minimize? Our function f, जो ऊपर defined किया x square plus 10 sin x. I want to minimize this f, and I have to give some starting point. x0. I have to give some starting point. You can give any starting point. Here I have given 0. You can change it and give any starting point over there. So this will do the minimization and it will print the result, and I will do print f of result.x. Just execute this part and see what you get. Just execute that. You should see this result. You get this. X is minus 1.3. X is minus 1.3. Can you verify with the figure? Around minus 1.3. That is where the minimum is occurring. And what is the corresponding f of this? वो भी negative है something. Minus 7 something. So the minimize function can easily find that. Now for doing this optimization internally, lots of algorithms are used. I'm not going into the details, but commonly used are gradient descent, conjugate gradient descent, stochastic gradient descent. If you are in machine learning, then these are very useful optimization techniques. So internally it is making use of all these techniques to determine the global minimum.
So minimize which of the gradient descent?
Inside this it is using BFGS. It's a Cauchy-Newton optimizer.
If I want to use like
Then you can specify in the syntax of minimize, you can do question mark minimize, you'll get the help. And then you can specify which optimization technique I want to use. You can explicitly define it.
So it already has that.
Default value is BFGS optimizer.
But it has the library for certain.
Yes, internally too. So SciPy is specifically for all that. Okay, so next we move on to pandas. Now pandas is another very powerful data structure in Python. We'll see how it is. So pandas is a library. I am importing here as PD. Import pandas as PD. So here I have the three imports. Import numpy, import pandas, import matplotlib.pyplot as plt. Percentage matplotlib inline means I don't have to write plt.show every time. If I do plt.plot, it will immediately show. I don't have to explicitly write plt.show. जैसे ऊपर लिखा था हमने. If you look here, I had written here plt.plot के बाद plt.show. Explicitly लिखना पड़ेगा वो. But if I write here matplotlib inline, I don't have to write plt.show. That is the meaning. It will save some effort on your side. So pandas is basically something known as data frame. Data frame. So this is how pandas data frame look like. So there is series of data, multiple series of data. This is, you can imagine like an array over here. This is the df index, df.index. df मतलब data frame. df.index मतलब row index, and df.columns मतलब column index. But the special part of pandas is you can have mixed data type. You can have mixed data type. You can have string as well as numbers. Both. वो जो numpy में possible नहीं है. Numpy, as I told you in the beginning, numpy is of fixed size, cannot change size, and same data type only. Whereas pandas can have multiple data types and is very flexible. We will see how it works. Data frame has this following functionalities. Df.info will tell you what are the different data types in this data frame. Df.head, it will show you the first few rows. Df.tail, the last few rows. Df.describe, give you a summary statistic. So let us explore. So I have just made up a IPL data over here. Just execute this and let us understand what is written here. So this IPL data, now look here and tell me what type of data structure is this IPL data? It is a dictionary. Why? Because opening and ending with curly bracket. And each element has key and value. Each element has key and value. So I have defined team, rank, year, points. These are my keys. और ये सब values है. 4 keys are there. Okay, and remaining values है. Notice that all these values are in a list. Dictionary के अंदर list. समझना है? Dictionary has 4 keys. Each key has a list of values. So you can put it like that. Now I am going to put this in a pandas data frame. Right now it is only a dictionary. I am putting this in a pandas data frame so that I can play with it. So PD on an import pandas as PD. PD.data frame. So data frame is a class of pandas. Data frame, I am just passing this dictionary. When you print Df, so if you execute this, you will be able to see this output. Notice how nicely it has printed the heading, column heading also. And what are these column headings? These are our keys. These are our keys. Now, let us do df.head. Execute this. df.head. df.head, you will see a very nicely formatted table. दिख रहा है?
Our headings like besides it.
Are you getting this output? Make sure you execute the previous cell and then you execute this cell. Are you able to see this output?
Yes, sir.
So what is happening here? Supervised and unsupervised. Now again in supervised, there are two different parts. Classification and regression. Classification and regression. If the output answer is distinct categories or distinct classes, तो बनेगा classification. Output is categorical, class 1 or class 2 or class 3. That is a classification problem. But if the output is continuous, real value, that will be a regression problem. Okay? So in supervised you have classification, regression. In unsupervised, you have to clustering and dimensionality reduction. Clustering means trying to find similar groups and putting them into clusters. Let us say I have 500 students in front of me, okay, and I don't know the correct class, I don't know the correct label, unsupervised, I just have the questions in front of me, I don't know their label. So in unsupervised learning, in clustering, if I have a set of 500 students, I will find some similarity between a group of students. Let us say some students fall in the age group of 20 years, so I am going to put them in one cluster. Some students fall in the age group of 21 years. I am going to put them in some another cluster. So I am going to find some similarity in this set of students and put them in different clusters. So every cluster will have some unique property. Okay, that is clustering. We are going to solve one algorithm. K means clustering. We are going to do that. And second is dimensionality reduction. So for example, a famous algorithm is PCA, Principal Component Analysis. So that falls under the category of dimensionality reduction. So if you have a data which is having huge number of attributes, large number of features, and visualizing a large number of features is impossible for us. We cannot visualize beyond 3 dimensions. If I have to plot something, maximum I can plot is in 3 dimensions, 2 dimensions, 3 dimensions. I cannot plot beyond that. So I cannot visualize. If I give you a data which is 10 dimensional, difficult for us to comprehend. So dimensionality reduction say we can reduce the number of dimensions while still retaining the information. While still retaining the information, reduce the number of dimensions so that we can visualize and do some interpretation of our data. So that is dimensionality reduction. So we are going to do all this today. Now for learning, some terminology is here. So here is an example. There are different instances or different samples, and each sample has different features, also known as attributes, and every sample or every instance has a class or a label. So this falls under the category of supervised learning, because every sample has some features or some attributes, and I already know the true label, true class of that sample. So this is supervised learning. And how many features are there in this case? 1, 2, 3, 4, 5, 6. 6 dimensions are there. 6 attributes are there. 6 dimensions are there. Okay, so that is called the dimensionality of the data. So typically we represent our data as N cross D matrix. Our feature matrix is X. N cross D matrix. N is the number of samples, number of data instances that we have, and D is the number of feature dimensions for each sample. So in this case we have a 4 cross 6 feature matrix, 5 cross 6 feature matrix, 5 samples and each sample having 6 features. And we also have Y, which is the class label. Class labels, this is feature matrix. So this Y is N cross 1. It is a vector. This is the class label. For every instance there will be some label, some class label, class 1 or class 2 or something. So this is what we need. We need X and Y. To do any machine learning, we need X and Y. X for a feature matrix, which represents our data, and Y is the class labels. So as I told you, in supervised learning, we have classification and regression. So regression means, suppose example, how much will that house sell for? I want to predict a numerical value over there. Okay, so output is a continuous value. Whereas over here, is this a picture of a cat or a dog? So output is a distinct category. That is classification. Then in unsupervised learning, as I told you, I have a set of people, I want to put them in different clusters, so I want something like this. Find some similarity in the set of people and put them in separate clusters. This is what I want to achieve in clustering. Okay. Feature selection, and I'm just telling you the basic principles of machine learning. Feature selection and feature extraction. So once we have X, which is N cross D matrix, maybe not all D dimensions are useful or relevant. So finding out the most relevant features, that is known as feature selection. Finding out the most relevant features from a data, that is concept is known as feature selection. You also have feature extraction, converting this D dimension features into some another dimension space, that is known as feature extraction. Example is PCA, which we are going to do hands-on. There is also a concept of overfitting, underfitting, and the bias variance trade-off. So let me give a simple analogy. If I am teaching to a class of students, and let us say 6 modules are there, and I have taught the students only 25% of the syllabus. Will the students be able to generalize well in the exam? No. So this is severe underfitting. I did not teach the students everything required for them to pass the exam. This is underfitting. If I, on the other hand, if I teach the students everything 100% and ask them to do rote learning, ratta maro isko, ye question ka answer ratta maro, will they be able to generalize in the exam? Thoda twist ho gaya exam question to? No. This is overfitting, zyada hi sikh liya, ratta maar liya, which is not good. What we want to do is achieve a generalization capability, not memorization capability. Our machine learning algorithm should be able to generalize on new data. Because not everybody जो class में पढ़ा है वही questions आएगा. That happens in Mumbai University, but not always in real life. Explain, right? They should be able to generalize on the concept. That is what we want the algorithm to achieve. The training should happen such that we want to avoid these two extremes, underfitting and overfitting. And we have a bias variance trade-off. Bias variance trade-off मतलब क्या है? What is bias? Bias means suppose the correct answer is suppose 80% and the student is getting consistently 60%. What the difference है? There is a bias over here. But if another student gets around 80%, it is very close to what I am expecting. So there is no bias over here. Okay. And variance is how far is the spread? Variance मतलब spread कितना है? So I want bias to be as low as possible. I want the unbiased performance, and I want the variance to be as less as possible. But there is a trade-off here. You cannot achieve best of both the worlds. You cannot achieve low bias and low variance. So there is always a trade-off. So when using a machine learning algorithm, there is always this conflict of bias and variance. Here I am showing you an example. Suppose I have two features and two classes. So this is feature 1 and this is feature 2. X1 and X2, two features. And I have two classes. Class 1 is represented by circle, class 2 is represented by plus. And I want to find a separating boundary between the two classes. So if I plot a line like this, maybe this is not good enough because this blue has gone over here, this plus has come over here. So there is some inaccurate decision happening over here. So that is underfitting. Whereas if I look here, if you look here, see what is happening. Exactly following the samples. But this is not good. This is like memorization. I am forcing, I want zero error over here. No error during training. So what will happen? The algorithm will form this curve. Notice that this is the line. What dimensional line? This is the high dimensional curve. It is trying to fit all training samples nicely. And I am trying to encode zero error. But this is not a good thing. This will result in overfitting. Because when a new test sample comes, it will no guarantee that it will be able to predict properly. Whereas this seems to be a good compromise. Some error is okay during training. What is more important is the testing error should be as less as possible. Training error zero नहीं हुआ तो भी चलेगा. What is more important, the test error should be as less as possible. The student performance in the exam is more important rather than student performing in an exam. So please scroll down and come to this cell. Here some imports here. First we are importing Numpy, we are importing pandas, we are importing sklearn. So sklearn is the package for scikit-learn. And certain aliases we are creating here. Logistic regression is a linear model. Why it is a linear model? Because it is linear in the parameter theta. So it falls under the category of linear model. So I am putting the alias as LM. Model selection and aliasing as CV. Grid search as GS. I will slowly explain to you what is the meaning of all this. This is for plotting and this is to show the plots. Just make sure you do shift enter over here. Shift enter on this cell. Shift enter on this cell. Okay. Now, if you look in the Explorer, go to the data folder, come to the Explorer. Inside the data folder, you will see some files. Go to the data folder. You will see some files. You will see Titanic train and Titanic test. Okay, can you open Titanic train? My Excel file will open. It's a CSV file. Excel will open. Titanic train. I want you to open in the Excel. First, let us understand what is written there in the Excel file. Can you see all this in the Excel file? Titanic train.csv. So first of all, the extension is CSV. CSV matlab comma separated values. See what information is here. Passenger ID, survived or not survived, 0 or 1. Passenger ka class, name of the passenger, gender, age, tickets, fare and so many other parameters. So this data is actually taken from the passengers who travelled on the Titanic ship. This is the actual data of the Titanic data set, standard data. So here you have Titanic train and Titanic test. So two things are already provided. So come to your notebook here. For reading these files, what we are doing? PD कौन है? Pandas. Pandas का here. PD.read_csv is a function, and we have to specify the path of that file. So it is inside our data folder. So data/titanic_train.csv, and likewise test के लिए read csv data/titanic_test.csv. What is the object type of train and test? They are pandas data frame. They are pandas data frame. So we can do head and tail. So let us do train.head. You should see the first, by default, first 5 rows. So same entries at the top that you saw in the Excel file. ऊपर का entries are same attributes. So basically these are the attributes over here, and these are the different samples. You can do train.head. You can try train.tail. Just try that. You can do test.head. Are you getting it? Yeah. All of you are getting this data? Near. File does not exist. It survived or not? So what I have done here is train is a data frame. Train.columns. I want only specific columns. Column number 2451. Dot head. Then I am going to use only this attributes. So what we will do is we will use 1, 2, 3. 3 features, and this is our label. This will become our class label. Survived or not survived. So for this simplicity, we are just going to use 3 features, not all the features. Okay? Just execute this. Do you see this? Okay. So what we will do is we will create a copy of that. Data equal to train of the specific columns. Specific columns dot copy. So I am creating a new pandas object over here. Train was the pandas object. Data frame. Train ka I am taking only this 4 columns. Dot copy. So now this is a new pandas object. Now in that sex column there was male or female, but I want numbers 0 or 1. So I use a simple boolean operator here. Data of sex equal to female. तो अगर female लिखा होगा तो 1 और male होगा तो 0 हो जाएगा. So I am just converting into 0s and 1s so that I get numbers that I can operate on. I cannot operate on strings. So this is a simple boolean operation. This line drop NA. It might be possible that you have missing values. For some passengers, some fields are missing. It's possible that for some passenger all information was not available. In that case, just drop that sample. Drop NA means drop the missing values. And data.head. So this is what you should see. True false, it is 0 and 1. Python will take it as 0 and 1. ये see in ऊपर जो है this is either male or female. तो मैंने क्या लिखा नीचे data of sex equal to female.
So true is female.
Female के लिए true, male के लिए false. Okay. ठीक है? Okay. Now, yeah.
We have taken the data only head or tail. If you want to take the complete data,
It is the complete. You are only seeing head and tail.
okay.
It is complete. We are only looking at the first few. If you try to do data.head of 100, आपको first 100 मिलेगा. Can you try data.head of 890? आपको सब 890 मिलेगा. There are 890 samples in that data.
So is it previous one train? It is training on the old data.
Whole, pura CSV का, everything is there. This head and tail is just to have a glance at our data set. Does not mean कि इतना ही है data. ठीक है? So all of you are here. Now we'll convert this into X and Y. What we want? N cross D matrix and N cross 1. X and Y चाहिए. So whatever is the data, you have to convert into X and Y. So I am converting this into everything into value so that false and true becomes 0 and 1. That false and true becomes 0 and 1, and I am converting into 32 with integers. If you notice, super 22.0, 38.0, some are floating points, some are integers. So here I am forcing everything to be integer, and dot values means false and true will become 0 and 1. Data underscore NP. Now this data underscore NP is 890 cross 4. Okay. There are 890 samples over here. It is 890 cross 4. This is column 0, column 1, column 2, column 3. What is X over here? X is 890 cross first 3. Barabar? That is what I want. ये पूरा 890 cross 4 है. उसमें से first 3 columns are my features, and the last column is my label, class label. So I am going to prepare X and Y. So देखो, X equal to data underscore NP, all rows, all columns except the last one. -1 मतलब last one. Starting from the first column till end, excluding the end. -1 मतलब last. So this will give me my X, and Y means all rows and only the last column. So this is the important step. You are preparing your X and Y. From the entire data, I have separated out X. The first 3 columns are my features, and the last column is my labels. And here you can have a glimpse of first few entries. Print X colon 5, comma colon, first 5 rows, all columns. Y ka first 5 rows. So you should see this. Make sure you get this output. Okay, good. देखो डेटा underscore NP is 890 cross 4 है ना, तो उसके अंदर we have like this column 0, column 1, column 2, column 3. उसमें से features are the first 3 columns और ये label है. So X will be all rows and all columns except the last one. So colon comma colon -1. Colon -1 मतलब all columns except the last column. And Y के लिए colon comma only -1. Only the last column. समझ में आया सबको X and Y. Now we have prepared our X and Y. So now we can implement a machine learning algorithm. So the first step क्या है? Given a data, आपको X and Y बनाना है पहले. You have to create your X and Y. X is N cross D, Y is N cross 1. Your first task is to prepare X and Y. Then you can apply the machine learning algorithm. Now we have to apply the machine learning algorithm, in this case logistic regression. Remember the 3 steps. What are the 3 steps? Create the model, fit the model, and test, predict the model. Okay. So before we do that, we'll do some analysis here. I am going to show you survival of male and female passengers as a function of their age. I have just written some code here to do a data analysis. I want to understand more about my data. So what we have done here is, I am defining a variable called female. Remember the first column was the column of sex, either 0 or 1, male or female. So I have X of colon comma 0, all rows and the first 0 column equal to 1. So this female will be either true or false. 890 cross 1, true or false. and survived is y equal to 1. Again, this is the Boolean operator. Y 1 अपना 8 90 cross 1, either 0 or 1. If it is 1, survived will be true, otherwise false. I am just creating Boolean operators over here. I want to see how many male passengers survived and how many female passengers survived as a function of their age. So define a variable age, x colon comma 1, all rows and the first column. So that column is corresponding to age. Now I am defining two variables, two dictionaries over here. This is what? Dictionary. This is the dictionary. So S is for the survived and D is for the died. S, male, I want to create a histogram. I am creating a histogram. Histogram for this variable age of only those who survived and not female. And second, that is for male. And female ke liye survived and female. This is for survived passengers. And D here is not survived and not female, not survived and female. So just execute this part. In the next cell, we will do the plotting. So you will not see any output on this cell, just execute it. You have to just write the first three, fill in the first three question marks. Okay. Now execute this next cell. So here I have just written a code for plotting the histograms. Execute this cell and you should see this figure. And now please make the interpretation something like this. Suppose you get this. What is the accuracy here? What is the accuracy here? Compare that. 100 upon 150. Accuracy is 100 upon 150. I'll give you one more example. What is the accuracy here? 110 upon 150. Now in these two examples, I am highlighting the fact that accuracy is not a good measure of performance. Accuracy is not a good measure of performance. If you look at any research paper, they will highlight that this paper had accuracy of 80% and with my proposed technique, the accuracy is 82%. But I am claiming that accuracy is not a good measure. Why? Because if you look in this case, if you look at this class, there is nothing wrong with this class. Perfect A. For D, it was able to perfectly predict all the negative samples. There was a problem with only the positive class. On the other hand here, the positive class is a perfect prediction. There is problem only in the negative class. But in both the cases, accuracy did not reflect that. Accuracy से पता चला कि positive class was correct or negative class was correct. Accuracy was not able to interpret that. Therefore, we need another measures such as precision and recall. Precision and recall. Only accuracy is not sufficient. Precision means how precise is my classifier. Recall means out of all positive examples, how much the classifier is able to recall. So basically precision is TP upon TP plus FP. Precision is TP upon TP plus FP. Out of all predicted positives, how many are actually correct? Here you go, TP upon TP plus FP. Out of all predicted positives, how many were actually positive? Right. And recall is this. TP upon TP plus Fn. Out of all actual positives, how many were correctly recalled as positives? Do either. So precision and recall are used. But again, only precision or only recall will not help in understanding the performance because they are two different things. Therefore, can we use both of these parameters? So that thing is known as F4. F4 is defined like this. It is the harmonic mean of precision and recall. If you simplify this, you get 2 PR upon P plus R. It is a harmonic mean of precision and recall. Why is that useful? Because it considers the benefits of both precision as well as recall. It is possible that, okay, let us consider here. What is the precision here? Wait, what is the precision here? See, accuracy here is 1 or 100%. What is the precision here? 100 upon 100. 100 upon 100 plus 0. 1. What is the recall here? 1. Very perfect. Ideal scenario here. Very difficult to achieve in real life. Let us consider this. What is the accuracy here? 100 upon 150. What is the precision here? 1. What is the recall here? 0.5. 50 upon 100. See, it is precise, but it is not able to recall properly. What is the precision? What is the accuracy here? 110 upon 150. What is the precision here? 100 upon 140. What is the recall here? 1. Either recall is good, but it is not precise. Okay, so the individually precision and recall will not help us to understand the performance of the classifier. But if you use the F score which considers both of this, then you will get some meaningful performance of the classifier. So therefore, always use F score for measuring the performance of the classifier. In the next few techniques, we will see how to calculate the F score using scikit-learn. But the basic concept is, don't depend only on accuracy. It can give you misleading information. You have to use precision, recall and F score also. Okay, so we have learned here that we are getting 82%. This can be improved by using more better advanced classifiers. So we'll take a break now. And we'll resume at 1:45. Okay. Supervised, unsupervised reinforcement. And we have seen one example of logistic regression. We are now moving on to the second one, that is KNN. KNN stands for K nearest neighbors. So here we are going to use the application recognizing handwritten digits. So to simply understand KNN, you have to remember this analogy. Tell me who your friends are and I'll tell you who you are. That is the simple concept of KNN. Basically, all similar people will be together. That is K nearest neighbors. So K nearest neighbors is actually not a learning algorithm, it is actually called a lazy algorithm. What is this lazy algorithm? In the previous example we have seen of logistic regression, what was being learned? That theta value was being learned. Okay? In logistic regression, so in logistic regression, we had x and y, and what was learned over there, that theta value was learned over there. So that is some learning is happening, which can be used during the testing. But in K nearest neighbors, no learning takes place. Everything happens during testing only. That's why it is called as a lazy algorithm. So, for example, let us say in this crowd of around 15-20 people, let us say some are from MCA, some are from computer engineering, some are from electronics engineering, for example. Okay. So I already know the labels of all the samples. So if I am a new sample, I want to find out who is my nearest neighbor. Now if I specify the value of k equal to 1, I want only one nearest neighbor. If I specify the value of k equal to 3, I want 3 nearest neighbors. So let me take k equal to 3. So I will find 3 nearest neighbors. Now question is nearest in what sense? Nearest in what sense? So maybe I will consider the attributes of all these samples. If I consider the attributes, some attributes of the samples, and if I can convert that into number, then I can easily measure the Euclidean distance. Once I can measure the distance using some distance measure, then the shorter the distance, the nearest it is to me. Now suppose I have found out 3 nearest neighbors from this crowd. Now I will find out the label of each of these 3. Suppose person 1 is from NCA, person 2 is also from MCA, person 3 is from computer. So I'll just do majority vote. I'll just do majority vote and then I'll conclude that my label is also MCA. Out of all the nearest neighbors, then I'll do a majority voting, that label will be my label. That is simple KNN. There is no learning that happens over here. All the work happens during the testing. So this is not a good thing. Why this is not a good thing? Because ideally training happens offline and testing is always done online. Training is done not in real time. It is done before you get the system in hand. And testing is always done in real time. So for example, in this phone, in most of the phones, speech recognition is there. You can speak and the machine can understand what you are speaking. Right? Speech recognition is there in most of the new smartphones. So when the phone is being manufactured, so using some machine learning algorithm, they will train that system. The speech recognition engine is there in that phone, so they will train it offline. So it is trained and then shipped with the phone. So that phone is now ready in the store. Now when you are using that phone during testing, you are speaking something and you don't want loading. Would you prefer that? No, you want quick answers. Testing should be real time. The moment you give the answers, we want real time answers. But what about this KNN? All the work is happening during testing. All the real work is happening during testing. So if I am speaking something, then it will extract the features and then do all the hard work of finding the nearest neighbors and then do the classification. So that is not a good thing. So this is an example of a bad machine learning algorithm. Still we are using it because in some applications it is still being used where real-time application is not there. So I am going to show you here recognizing handwritten digits. So whatever theory I spoke, all that theory is already written over here. So here the number K, that is known as the hyperparameter of the model. So this is the new terminology, hyperparameter. What is hyperparameter? This is not a parameter of the data. This is the parameter of the algorithm. So that is the hyperparameter. So there are two things, parameter of the data, which comes from the features. But this K is not dependent on my data. This K is for the algorithm, machine learning algorithm. So that is a hyperparameter. So depending on your K, the performance of the algorithm can change. So that is a hyperparameter that has to be set properly. Let us come to this cell and please fill in the blanks. So most of the well-known data sets are already inbuilt with scikit-learn. So import sklearn.datasets as DS. So sklearn API library is there, inside that datasets class is there. So that we are importing as DS. Digits equal to DS dot load digits. So load digits is a function which will load this dataset for us. And for any dataset we want X and Y. So X is digits dot data, Y is digits dot target. Please execute this cell. Here I am printing the minimum value of X and the maximum value of X, which is coming here, 0 and 16. Now this handwritten digits, let me show you, they look like this, very low resolution images. These are low resolution images and the scale of values is only 0 to 16. Minimum pixel value is 0, maximum pixel value is 16. That is the range of pixel values. Print x dot shape. X dot shape. The dot shape will tell us the size of the matrix. 1797 samples are there. 1797 images are there. Each is of 64. This 64 is basically it is a 8 cross 8 image. It's a very low resolution 8 cross 8 image, which it has reshaped into 1 cross 64 in a raster scanning order. Okay. Image is 8 cross 8. Like I show you here, this is the 8 cross 8 image which it has reshaped as 1 cross 64. So there are 1797 images, each is of size 1 cross 64. Print y colon 15. Y, what is y? Y get defined here, digits dot target. So that is the label of each image. That is the actual value of each image. So the first 15 images have this labels. Digit 0, digit 1 and so on. X2 colon 2 comma colon 10. What is the interpretation of this?
Starts from
Second image, second row and the first 10 pixel values. First 10 columns. First 10 columns. See, X digits dot data. X is 1797 cross 64. X is 1797 cross 64, which means image 1, image 2, image 3 up to image 1797. Itna rows hai na? And then each image has pixel value 1, pixel value 2, pixel value 3 up to pixel value 64. So here I am saying x2 comma colon 10. So the second image, this is 0, 1, 2. 0, 1, 2. Second image का first 10 pixel values, which is being shown here. You see that? Okay. This is our x and y. You can execute this. So I am just displaying some of the images here. You can see here that I have used subplot over here, and I am doing mat show. So display the image as a matrix, 8 cross 8 matrix. You should see this result on executing that. Since it is a low resolution, but still you can figure out the images 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now this is our data. We have our x and y ready with us. Now we are going to use the KNN classifier. As usual, we will do train, test, split. Remember, two things are happening: ANC.predict and then accuracy score between y predicted and y test. So please execute. You will get some value. Your value may not be same, but you should get some value. What value are you getting?
977.
Around 97% you are getting. Okay. So this is a very simple data set, very small data. So that's why you can get. Let us draw a synthetic image of digit 1. So I want you to understand this properly. So I am drawing a synthetic image of digit 1. Please look at this and try to understand why is this a digit 1. So take some time to think, why is this image of digit 1? Please think. So I am creating a 8 cross 8 matrix initialized to 0. 8 cross 8 matrix initialized to 0. Focus on these two lines. Why is this a digit 1? You can use a notebook and think. Use notebook and pen and think, why is this a digit 1? Look at the indices properly. You have created a 8 cross 8 0 matrix. So you have to think about 1 colon minus 1 comma 4 and 2 comma 3. Does that make the digit 1?
Sorry, here 16 is intensity.
Intensity, pixel maximum intensity. 16 here is the maximum pixel intensity. Focus on the locations. 1 colon minus 1 comma 4 and 2 comma 3. 1 colon minus 1. So starting row is the second row. 1 से लेके second last तक. And then fourth column. So that will be completely white. वो पूरा एक 1 का 1 बनेगा. And then 2, 3. So it should look like this. Second row, third column. So just execute that. Are you getting the image? So now we have created a synthetic image. Let us see whether the k nearest neighbor classifier can predict this as digit 1. Right? So in the next, since we have created a 8 cross 8, we need to reshape it into 1 cross 64. So 1 dot reshape 1 comma minus 1. We are going to use reshape and then use KNC dot predict. KNC dot predict. So I am getting answer 1. Hopefully you will also get answer 1. Just execute. It should predict it as digit 1. Are you getting answer 1? All of you there are getting answer? Answer 1? Okay? So this KNN, what we have done so far is on a very trivial data set. Now let us use a very interesting data set called iris data. Okay. So what is this iris data set? Iris data set is a data set of flowers. There are 3 flowers which I am showing you here. Setosa, versicolor, virginica. Okay, please make sure that you understand this data set properly. There are 3 types of flowers. So one scientist known as Fisher Iris, he collected data samples of these 3 types of flowers, Setosa, versicolor, virginica. So he created a data set, 50 samples of each class. He used 50 samples of each category, 50 samples of Setosa, 50 of versicolor, 50 of virginica. Then he measured some attributes of these flowers. What attributes were measured? Here. The petal length, petal width, the sepal length and the sepal width. These 4 attributes he measured for 150 flowers. 50 samples of each category. Okay, so total 150 flowers. And 4 attributes or 4 features or 4 dimensions for each sample. So what is X in this case? N cross D क्या बनेगा? 150 cross 4. There are 150 samples. Each sample having 4 attributes. What are those 4 attributes? Sample length, sample weight, petal length, petal width. And what will be Y corresponding? N cross 1, 150 cross 1. In this, the first 50 are Setosa, the second 50 are versicolor, the next 50 are virginica. So this is how a data set is built. So let us look at that data set. Open, go to your Explorer folder. You will see a iris.csv file. Open that file. In the data folder, look at the iris file. You should see this data set. Sepal length, sepal width, petal length, petal width, and then the last column is the species. You will find 50 of Setosa, right? Then 50 of versicolor, and then 50 of virginica. Now one very important point to observe over here. Look at the first 4 columns. So the first column is in the range of around 4.5 to 5. First column, if you look at the first column, it is in the range of around 4.5 to 5. Whereas the petal width column, if you look at that column, it is around 0.2, 0.1, it is also going to 1.4, 1.5. So the idea over here is, these 2 features are having different scales. These 2 features are having different scales, which is not a good thing. Why? Let me give you an example. Suppose we want to predict whether an employee should get an increment or not. So I can consider the various attributes. Age can be an attribute. Working hours can be an attribute. Okay, and the existing salary can be an attribute. So these are the various attributes. Very clearly, all these attributes are having different scales. So age can be in the range of, let's say, 25 to 50 or something like that. Salary can be in the range of 50,000 to 1 lakh. The scales are totally different. If we use that data as it is, that is not a good thing, because we are learning in totally different scales. Because what will happen is, suppose I just add up everything. So if the age is 50 and the salary is 50,000, so this addition will become like this. Clearly, this dominates. Clearly, that feature dominates the other one, which is not a good thing. We want to give importance to every attribute. Therefore, what is done is normalization or feature scaling is required. Feature scaling is required so that you bring everything in the same range. You bring all the feature in the range of 0 to 1. We are not doing that immediately, but that is an important concept that you must understand. We have to do feature scaling so that all features play an important role. Okay, now come to our notebook. So we can load the iris data set from the CSV file, or scikit-learn also comes inbuilt with that data set. So we will use that for here. So import sklearn.neighbors.me DS. What is that DS? Earlier we done import sklearn.datasets as DS. So ds.load iris. Earlier we done ds.load digits. Now ds.load iris. This is the inbuilt data set. And what is our x and y? X is iris data, y is iris traffic. What we'll do is go to cell, go to edit and click on split cell. So now this one cell I am splitting into two cells. After we have defined x and y. Okay, so it should now get splitted into two cells. I splitted one cell into two cells. Okay, now what we can do is just type here x dot shape. Press shift enter. I want you to understand the dimensions of x and y. You press x dot shape. You should see 150 cross 4. That is what I explained to you here. 150 cross 4. You can also look at y dot shape. That should be 150. Let us look at x of 3 comma colon. X of 3 comma colon मतलब क्या? Third flower all features. Third flower all features. And if you do colon comma 3, what will be that? All samples का third feature. Right? Okay, so now we have x and y. We will instantiate, create the model, Engg.k equals classifier. Here I am specifying k. This is specifying the value of k. And underscore neighbors is the value of that classifier. So I am specifying k equal to 5 over here. So this is creating the model, fitting the model k equal to x comma y. And I am taking a totally new feature and let us predict what it is. So can you execute this? Yes, I am getting versicolor 3542. getting? All of you getting the answer, versicolor? Now, besides the answer, it can also predict the probability. So, if you execute this, predict underscore PROBA, so it can give you the answer in terms of probability also. So, if you notice here, 0, 0.8, 0.2, how much you are getting? Same, right? So, what is the interpretation here? It is only 80% confident that it is versicolor. It thinks 20% that it is virginica. That is the interpretation here. It is not 100% confident. So, therefore, if you are doing research in machine learning, this concept is very important. This concept is very, very important. So, there are two types of decisions that can be made. A hard decision and a soft decision. So, if you are familiar with fuzzy logic, there is a crisp logic and there is a fuzzy logic. So in hard decision, you for sure say that either it is class 0 or class 1, 100% confidence. You can be either totally right or totally wrong, which is not a good thing. But if you give the answer in terms of probability like this, 80% I am confident it is versicolor and 20% I think it is virginica. Accordingly, then you can take it further and do some further processing on it. This is soft decision. So soft decisions are better compared to hard decisions. You can't be either completely right or completely wrong, because in that case false positives and false negatives will be very high in case of hard decisions. But if you have soft decisions, those false rates can be reduced. Now, just in that folder, can you check if you have these files, some Python files? Do you have those Python files? Plot iris knn.py. Do you have these files with you? Yes, some files here, plot iris knn, plot decision region. Those files are there with you? .py files. So those scripts are given to you. Now come to your notebook. So this here I am showing you. So if there is a Python script, how do I run that script in my notebook? So just do run and the name of that script. Just execute that. You should see an output like this. Run followed by space and the name of that script. You should get this output. So in that script, what I have written is using this iris data set and only 2 features. Because the iris data set consists of 4 features which we cannot visualize. So I have used only the first 2 features and I have plotted the decision boundary for each of the 3 classes. Decision boundaries for each of the 3 classes. Class 1, class 2, class 3. And I have used sepal width and sepal length only. What interpretation do you make from here? Overfitting. Overfitting to some extent, okay? What else? That class 1, no problem. This is perfectly fine. But there is some overlap in these 2 classes. Which means only these 2 features may not be effective. Only these 2 features may not be effective. Of course, you can do play with this and use sepal length, petal length. You can experiment with sepal length, petal width. You can experiment with that and check where you are getting. But all 4 features are required to result in a better performance. Using only 2 features is not sufficient. If you want only 2 features, then after some time we'll work with PCA and check if we can get better results with only 2 features. Okay, so that was KNN. The third application here, the third algorithm is the naive-Bayes classifier. And for doing this, I am going to use an NLP application, natural language processing application, so that Kaggle competition is detecting insults in social commentary. So many people now use Twitter, Facebook and Instagrams, and they comment, and there are many trolls out there. You have heard the word troll, using abusive language or insulting people. So given a text, given a paragraph of text, detecting whether it is insult or not an insult, that is a challenge. Okay. So for this, we are using, I have given you the hyperlink. This is data set created by this company called Inferium and used in the Kaggle competition. So we are going to use the naive-Bayes classifier here. So some theory about naive-Bayes. These are the two people famous for Bayes theorem. Laplace, you must have heard about Laplace transform, and Bayes theorem, so that is Bayes. Why Laplace is also famous for Bayes theorem? Any idea? All of you have heard Bayes theorem? Laplace का भी नाम सुना होगा, right? Why is Laplace famous for Bayes theorem? So there is a history for it. So Thomas Bayes, during the period that he was alive, he wrote a paper, essay on the doctrine of chances. So he wrote this 50 pages paper and he sent it to his friend Laplace. And that paper did not get published and he died. Bayes died. So Bayes theorem was not famous when he was alive. So after his death, Laplace published a paper in his name after his death. So therefore Laplace is also famous for Bayes theorem because he helped Bayes to get famous. Okay. This is the Bayes theorem. You can recall from your engineering. This is the Bayes theorem. There are 4 terms over here in the Bayes theorem. I'll spend 5 minutes here to explain you Bayes theorem. This is marginal probability, also known as prior probability. This and this are conditional probabilities, and this is the total probability. Okay. So what is this and what is this? Both are conditional probability. But what is the difference between this and this? What is Bayes theorem used for? What is the purpose of Bayes theorem?
Probability of one thing happening when one thing is given.
So that is conditional probability. So there are 2 conditional probabilities here, na?
It is
When reverse is known.
We can reverse this. अब करना क्यों है? Why to do this? Equal to 0, y equal to 1. So this is a binary communication channel. Right? This is transmitter and this is receiver. If I assume that these are equally likely, uniform distribution bola, so therefore probability this will be 0.5, probability of this will be 0.5. This is the prior probability. Before the event actually happens, that is prior probability. I have some knowledge about the source, that is prior probability. Now I actually transmit. So I will get P of y equal to 0 given x equal to 0, or I will get P of y equal to 0 given x equal to 1. In both cases, this is possible. I transmit this and I get this, which means there is no error. I transmit this and I get this, there is an error. On the other hand, I transmit this and receive this, error. Transmit this and receive this, no error. 4 possibilities are there. So this is the likelihood. This is known as likelihood. This is known as prior. This is probability of that event before the event actually takes place. Prior information. This is now the event has taken place. What is the probability of receiving this given that this was transmitted? So this is called likelihood. Now having received y equal to 0, I want to update this information. What is the probability that having received 0, I actually transmitted 0? For this, Bayes theorem is used. This is known as posterior probability. This is posterior probability. So updating your belief after the event has taken place. Initially we have only P of x equal to 0. This is our prior belief. I think that there is a 50% chance. Or maybe if it is a biased one, I can say 70-30 chance. So this is our prior information. Then the event takes place. So I get a likelihood. What is the likelihood of receiving this given that you transmit? And I want to go back here. So this is also known as the inverse probability. I want to update my prior belief. So this is now become a posterior probability. Okay, so putting it over here, I will get P of x equal to 0 given y equal to 0. If I apply the Bayes theorem, this will be P of x equal to 0 prior multiplied by likelihood, right, divided by x equal to 0 given y equal to 0 plus P of x equal to 0 given y equal to 1. This is the total probability for P of x equal to 0. So that is the total probability, also known as marginal probability or also known as L dash. So these are the 4 terms used in the base theorem. Left hand side is posterior. In the right hand side numerator में prior multiplied by likelihood divided by marginal. Okay, so it's important to understand the meaning of this 4 terms. That is posterior probability. Let us put it in action. So there is a troll data set from the Kaggle competition. So that is the link over here. You can refer to that link later. So execute this imports. Some standard imports we are making. We are importing Numpy, pandas, sklearn, model selection, feature extraction.txt, naive base, and pyplot. So execute that cell. Now go to your Explorer folder. In the data folder you have troll.csv. Can you open that file? In the data folder you have troll.csv. Please open that file and see what are the contents of that data set. So this is the data set from the Kaggle competition which we are going to use. So insert date and the comment. So some comments are there and whether it is insert or not. So that actual label is already given. So we'll ignore the date for now and just focus on the comment and the insert part. So let us come to the notebook. So pd.readcsv data/troll.csv. So just execute this. This is what? Pandas data frame. That's the data frame. And let us look at df of only the 2 columns, insert and comment, dot tail, so the last few. Looking at this number, can you tell me how many samples are there? How many samples are there? 3947. Because it's starting from 0. Pandas data frame is starting from 0. 3947 are there. But now, this is very interesting because so far what did we have? See, in the early afternoon we did Titanic data set. In the Titanic data set we had age, the gender, passenger class, everything was numbers. In the iris data set also everything was numbers. Sepal length, sepal width, petal length, petal width. But now comments, that is text, characters, string, they are not numbers. So now we have to do some extra effort to convert them into numbers. Now our data does not contain numbers. Our data contains text. This is a very important thing here. So this is a natural language data. It is not numerical data. It's a natural language data. And the target is simple 0 and 1. Insert or not insert. So let us define y. This is very easy. Y equal to df of insert. So it's a simple n cross 1. Execute this. Y equal to df of insert. So we have defined y. Now task is to define x, which is a hard task. How to define x? So from the text characters, the question is how to determine the feature matrix. The feature matrix should be n cross d. X is n cross d, y is n cross 1. Okay, so y is already done. Y okay. Now how to get x? N cross d. The input is not numerical. The input is text string. So how do we convert it into numbers? So for text processing, to convert into features, there are many techniques available. The most trivial technique is just count the frequency of all the words and use that as a feature. But if you use that technique, there are infinite possible words. Vocabulary can be huge. So you cannot rely on that technique. So one technique is TF-IDF. One technique is TF-IDF feature. So I'll explain to you what is that. TF means term frequency, IDF means inverse document frequency. Term frequency, inverse document frequency. So product of two terms. So definition of term frequency. Just read the definition of term frequency. Term frequency of a term T is number of times term T appears in a document upon total number of terms in the document. Very simple, straightforward. How many times that word T has appeared in this document divided by all the words, total number of words in this document. That is how frequent this term T is occurring. Very simple, term T. But it is possible that a particular term is very rarely occurring in the entire corpus. Corpus means the entire set of comments. Let us say here in this case I have around 3000 comments. A particular word is occurring very rarely and occurs in only one document. Suppose it is a very rare word and only occurs in one document. In that case, TF of that term T will be very high. But then if you look at the entire data set, it's a very rare term. So why to give a high importance to that? It's a very rarely occurring term. If a term is occurring more and more, you should give more weightage to that. So because of that, we use inverse document frequency. Inverse document frequency. So words like is, of, that, they're very commonly occurring words. उनका importance ज़्यादा नहीं होना चाहिए because they are not specific to that particular comment of insult or not. We should downplay the importance. So IDF of a term T is log E मतलब natural log of total number of documents upon number of documents with term T in it. Now what is this? Total number of documents. Let us say you have 1000 documents divided by number of documents with that word. So now if there is only 10 documents with that word, IDF will be high because of denominator में. But if there are 500 documents with that word, numerical value. So let us apply this on this data set, whole data set. So here text.tf IDF vectorizer, we are instantiating this feature extractor. tf.fit underscore transform. What is the text df of comment? This is the column where all the comments are there. Then we are passing to tf. Tf is this. Tf IDF vectorizer. tf.fit underscore transform. It will fit and then it will transform. The transform will result in numerical values. Now print x.shape. So now we will execute this and check whether we are getting the output. Shape. What is the interpretation of this? इसका क्या interpretation? Are you getting this output? What is the interpretation? There are 3947 documents. 16469 unique words in the data set that we have. 16,469 unique words are there. So ये बनाती है n cross d. This is n cross d. But this is a very sparse matrix. This is a very sparse matrix. What is that sparse matrix? Sparse matrix means very few entries are filled. In that matrix, it is not a dense matrix. Not every entry is filled. It is a very sparse matrix. Why? Because not every word is going to appear in every document. So that's why print x.nnz. nnz means the number of non-zeros. Total number of non-zeros. Total number of non-zeros is 1,259. Can you determine the sparsity of this? How to determine the sparsity? What is the total number of words? 3947 multiplied by 16469. These are the total number of words. But only 100269 are non-zero. Can you calculate? कितना आ रहा है? Please do a quick calculation. Use the calculator. How much is this? data is non-zero. Only 0.1% of that matrix is non-zero. बाकी सब zero है. This is a sparse matrix because not every word occurs in every document. Okay. So here I am showing print x colon 1 colon 1 x colon 1. So here I am showing for the first document. First document at this index, for this word with this index, has TF-IDF of this. In that document, word with this index, TF-IDF is this. In that document, word with this index, these are the TF-IDFs of only that document. You can see, scroll down, only limited number of non-zero words are there in that document. And these are the TF-IDFs. What we have done, we have converted text into feature, numerical feature using TF-IDF, and it's a very sparse matrix. Okay. Now, having got that, yeah, each sample has, it's already done here, 0.15% of non-zero features. You can execute that. Okay. Now, time for training testing. So we have to do train test split as usual. So train test split, so we have to pass x, y and test size. By default I have specified 0.25, which will return as x train, y train, x test, y test. So execute this. Okay. So after that we will use a naive-based classifier. Now there are two types of naive-based classifier. If the output is anybody here getting an error? You have to remember. Okay. Are you getting? Okay, now there are two types of NB classifier, naive-based classifier. If the output is binary, either this or that, then we use a Bernoulli naive-based classifier. But if the output is continuous or real numbers, then we use Gaussian naive-based classifier. In our case, we have a binary situation, either insert or not. So we use a Bernoulli naive-based classifier. Now, important to understand what is happening here. Bnb equal to cv dot grid search cv in bracket nb dot Bernoulli nb comma parameter grid alpha here. So I'll explain to you what is happening here. First of all, we are creating this model. Naive-based classifier is created over here. Nb dot Bernoulli naive-based classifier. Now, this particular classifier has a parameter known as alpha. Just like in logistic regression, we had a parameter theta. Just like that, this Bernoulli naive-based classifier has a parameter called alpha. So I want to find that value of alpha which will give me the best result. So I am specifying in the syntax over here the possible values of alpha. So how did I specify that? Parameter grid. I am specifying the grid of alpha. Alpha is nt.log space minus 2, 2, 50. What is the meaning of this? nt.log space. So logarithmically spaced numbers minus 2 to 50. Matlab this is starting number is 10 raised to minus 2 till 10 raised to 2 and 50 numbers in between. Okay, this is not linearly spaced. It is logarithmically spaced. What are the different values of alpha we are specifying here? From 10 raised to minus 2 to 10 raised to plus 2. And I want 50 numbers in between them. These are the 50 possible values of alpha that I want to try. That I want the algorithm to try. And for doing that, we are doing grid search CV. CV basically is cross validation. CV means cross validation. So I am going to try different values of alpha, and the one which gives the best performance, I am going to use that for training. Okay, so in one line directly we have done this. What we have done, we have created this NB model I am specifying the range of alpha and I am doing grid search thing. In the next line, we are fitting that naive Bayes classifier by passing X train, Y train. Please execute this. You can see the various 50 values of alpha starting from 10 raised to minus 2. It's important you understand how to read this. 1 dot E minus 02. This E matlab 10 raised to minus 2. 1 E minus 2 matlab 10 raised to minus 2. This is 10 raised to plus 2. From 10 raised to minus 2 till 10 raised to plus 2, 50 numbers are there. Which may dot 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 is there. So we have created and we have fitted. Now, as usual, we can also do predict and then find the accuracy score, or we can directly do dot score. When we use dot score, we have to pass the Y test also. But remember that Y test is used only for accuracy score, not for doing the actual prediction. So tell me your answer. So I am getting around 69. 9.72. Wow. Okay. 75. So everybody will get different answer, obviously, because we have used train test split. Okay. Why should we rely on this only? Let us use our own sentences. Let us create our own comments and check whether ये insert predict कर रहा है. It is a naive assumption, but that may not be a valid assumption. That may or may not be a valid assumption. So therefore you have to use a better probabilistic classifier to overcome that assumption. Okay. Let us move on to the next one. Next one is the interesting one, SVM, support vector machines. Fourth one is SVM. So here, look at this figure. So consider two features and two classes. Feature x1, feature x2. These are the samples of class 1. These are the samples of class 2. The question is, I want to find a boundary which will separate class 1 and class 2. That is the goal. I want to find a boundary which will separate class 1 and class 2. Now as you can see here, we have drawn 3 lines. So which line is best? That's the question to you. You have drawn 3 lines over here. Which boundary is the best according to you? Which boundary is the best according to you? Very difficult to answer. Just by looking at this, there are infinite solutions possible here. There are infinite solutions possible here. I can draw like this, I can draw like this, I can draw like this, I can draw like this. There are infinite solutions possible here. What does support vector machine do? It will do this. It will find a boundary that maximizes the margin. What is that maximize the margin? So this is the boundary and this is the margin. So this margin is the one which passes through the vectors of a particular class. So this is the vector of this class, there is a line passing here. These are the vectors of this class, there is a line passing here. So this is the width, this is the margin, and this is the midpoint of that margin. The goal here is to maximize this distance as much as possible. Why? Why maximize? Why not minimize? Why not minimize the margin? If we minimize the margin, then what will happen? Lot of ambiguity. You will not be sure of the results. But if the margin is far apart, तो थोड़ा सा भी error अगर होगा, तो that is tolerable. Okay, so suppose this sample, if it comes here, still it is beyond this boundary, so it will be correctly classified. But if the margin is too small, even a little bit error can lead to misclassification. So the goal of support vector machine is to maximize the margin. Choose that boundary which will maximize the margin. So this is the optimization problem. It is a quadratic optimization problem. And what are support vectors in support vector machines? The vectors through which the hyperplane passes, those are known as support vectors. So this 1, 2 and 3, these are known as support vectors. every other vector can be discarded. So over here learning means finding the decision boundary and finding the support vectors. That is the meaning of learning of SVM. This is a very widely used algorithm for classification. It is important that you understand this. Now in this figure, since it is a two-dimensional space, our boundary is a line. Our boundary is a line. If we go for three-dimensional, then the boundary will be a plane. If we go for four-dimensional and above, the general term is hyperplane. In 2D, that boundary is known as line. In 3D, the boundary is known as plane. In 4D and above, the boundary is known as hyperplane. Now, in this 2D space, we have this straight line. And we know that the equation of a straight line is y equal to mx plus b, y equal to mx plus b. In this case, y equal to w transpose x plus b. X, what is x? The features. In this case, x1 and x2, two features. Y one है the label, either class 1 or class 2. So the goal is to find this weight and the bias. Weight is the slope over here. Weights and the bias. Bias is the y-intercept over here. So the goal of SVM learning is to find this hyperplane. Of course, as we move on to 3D and higher dimensions, the equation will have corresponding terms related to plane and hyperplanes. Now over here, this equation is this decision boundary W transpose x equal to 0. Let us say this is W transpose x equal to 0. This is W transpose x equal to minus 1. This is W transpose x equal to plus 1. So in SVM, the target label should be either minus 1 or plus 1. We should not use label as 0 or 1. SVM learning will not happen in that case. Why? Because the boundary is at 0. Boundary ka either minus 1, boundary ka either plus 1. Only two labels are possible in SVM. It's not 0 and 1. It is minus 1 and 1. So therefore, when using SVM, it is important that your y, the label vector should consist of minus 1 and 1 and not 0 and 1. This is a common mistake which people make. When using SVM, we should use minus 1 and plus 1 because that is how SVM is designed. So the goal here is to maximize the margin. And mathematically, this is the optimization equation. This is the optimization equation. So that margin, by doing some geometry, the margin comes out to be this much. If you apply some geometry in that figure, you can find out the margin width is 1 upon norm of W. This double vertical line means L2 norm. The Euclidean distance of the weight vector. W is the weight vector, this is the L2 norm. The Euclidean distance of W. So we want to maximize this. Maximizing this is equivalent to minimizing this. But maximizing this is equivalent to minimizing this. And minimizing this is equivalent to minimizing W transpose W half. Because this is better when taking the derivatives. इसका derivative लगे तो 1 हो जाएगा. E by dW of this will become 1. But if you take the derivative of this, it will become 2W. And 2 will get cancelled. So W will remain. So analytically this is better. And hence we get this term here. We want to minimize this. Remember, we want to maximize the margin. Margin is 1 upon norm of W. It is equivalent to minimizing this. So this is what we want to minimize. Now there is extra term over here. So this is a regularization term to avoid the overfitting. So how does this help in avoiding overfitting? Zeta I. So what is that zeta I? Look at here. This is optimize this, minimize this, subject to. So if you are studying linear programming, you have maximize or minimize subject to some constraint. These are the constraints here. What is the constraint here? yi is the label. It is either minus 1 or plus 1. Yi multiplied by, this is like mx plus b. I'll shortly explain what is this phi later. This is like mx plus b by I into this greater than equal to 1 minus beta I, and all beta I should be greater than equal to 0. So basically we are saying if this is the boundary and this is the margin, let us say all the samples are here. This is the ideal world scenario, nicely separated. But it is possible that some samples are over here. This is still tolerable. But it is also possible that this sample is there and this sample is here. Possible, right? This is possible. In order to avoid overfitting, we don't want a boundary like this. We don't want a boundary like this. Memorization nahi karni. We want generalization. So therefore, how much penalty to give to this variables which spill over the boundary? कितना cost penalty देना चाहिए for the vectors which go in the other side? This actually belongs to this class, but now it is this side of the boundary. This belongs to this class, but it is now this side of the boundary. So this beta I takes care of how much penalty we should give for this vectors which spill over the boundary. Okay. So how much penalty? C is the cost penalty for that. C is the cost penalty for that. So C here is a hyperparameter. The parameter C is a hyperparameter which has to be fine-tuned. We have to select the proper value of C. Otherwise the SVM by default, if you use the default SVM, C is 1. You may not get the best result. But if you fine-tune SVM algorithm by properly tuning the value of C, you will get the proper results. We use linear SVC on non-linear data. Let us come down. So I am just using the XOR table. So I am going to get like this. I am going to get a non-linearly separable data. So I have used the logical XOR to create the data like this. Class 1 is over here, class minus 1 is over here. I am going to use this is clearly non-linearly separable. Then creating the classifier svm.linear svc. Now let us fine tune that classifier C. So C I am specifying. Can you tell me what is the range of C here? What is the range of C here?
Log space 10
raised to minus 3 till 10 raised to 3, and there are 10 raised to here. And all this is put in a grid search cross validation. So that will be the estimator. I am going to fit estimator.fit x comma y, and again use that plot decision function. So execute this, and now let us look at the decision boundary. You will get this. What is your interpretation? What is your interpretation here? What is your interpretation here? Using a linear separable boundary on a non-linearly separable data is not good. See, upper bhi same class, niche bhi same class. This is clearly not good. So we cannot use a linear SVM. We have to use a non-linear SVM. So the question is how to use a non-linear SVM. For that, we have to do something known as kernel trick. We have to apply some kernel. What is this kernel? I'll explain with a figure. So if you look at this data, here, 2 dimensions, 2 classes. Is it linearly separable? No. Circularly shaped data. It is clearly not linearly separable. So now, right now the data is in 2D, 2 dimensions. But if I project onto higher dimension space, if I project onto 3D by applying some function phi, and look at this. In 3-dimensional space, it is very clearly linearly separable. The separable boundary is a hyperplane, is a plane over here. So if I project my data from 2D to higher dimensional space 3D, so hopefully in the higher dimensional space the data will become linearly separable. So that is the kernel operation. What is the kernel operation? Projecting your data from low D to higher D, so that the data in higher dimension becomes linearly separable. That is the main purpose. So we are going to use kernel for that. There are various kernels available. The different kernels are linear kernel, polynomial kernel, RBF kernel. The most popularly used is RBF kernel. RBF का full form है radial basis function. Radial basis function, and it behaves exactly like a normal distribution. Again, why normal distribution is very important. Now, let us do the same thing of XOR, but this time with a non-linear SVM. So what has changed over here? Earlier we had SVM.linear SVC. Now only SVM.SVC. In the previous case we had SVM.linear SVC. Now only SVM.SVC. Now this kernel, RBF kernel is, one second. This RBF kernel this is the formula of that RBF kernel. This is the formula of RBF kernel. So kernel here is basically the distance between x and x dash. So if there are two vectors, x and x dash, this is e raised to minus gamma norm of x minus x dash square. So it will be like this: e raised to minus gamma x minus x dash square. This is the distance between two vectors x and x dash. If you were to plot this, this is similar to Gaussian curve. So let us try to understand the interpretation of this over here. Suppose this is x dash. Suppose this is x dash. I am just using 2D as a 1D as an example here. Suppose this is x dash. If x is very close to x dash, if x, another value, is very close to x dash, what will happen to this value? Please think and answer. If x is very close to x dash, what will happen to this? क्या बनेगा? ये फाइनल आंसर क्या बनेगा? What will happen to this? E raised to 0 is 1. So the distance will be approximately 1. But if x is very very far from x dash, then what will happen to k? E raised to a minus a big number. E raised to minus a big number is approximately 0. So if x is very close to x dash, give it more importance. If x is very far from x dash, give it less importance. That is what RBF kernel is doing. Okay, that is the interpretation of this formula here. If x is very close to x dash, give it more importance. Distance k is 1. If x is very far, then give it less importance. Okay. So this gamma over here is one more hyperparameter. One hyperparameter was C, the cost penalty. कितना error tolerate करना है अगर spill हो गया तो. And this gamma is for the kernel. Okay. So there are two hyperparameters in SVM, C and gamma. So therefore, over here, so now over here, in the grid search, you can notice there is a grid for C as well as a grid for gamma. What is the range of gamma? Again same, 10 raised to minus 3 to 10 raised to 3 and 10 values are there. Once we have created, so earlier we had linear SVC, now we have only SVC. Grid search CD, we are fitting it and again plotting the decision function. So execute this and see what you get. So I am getting like this. Yeah. All of you getting this figure? So now it is very clear that the boundary is non-linear. This part and this part is for class 1 and this is for class -1. So very nicely it has separated in a non-linear manner. Now the decision boundary is no longer a line, which was the case in the previous one. Now it is a non-linear boundary. So we have to use a non-linear SVM. For real life data, always use kernel SVM. Now let us apply SVM on the iris data set that we studied earlier. Let us look at the code here. We are importing pandas, import Numpy, import data sets, import matplotlib. Loading the iris data set.load iris. We want X and Y. For simplicity, I am taking only the first two features so that we can plot on 2D axis. Remember, this data consists of 4 features. But to visualize properly, I am using only 2 features. The iris.data colon comma colon 2 means all rows, 150 rows, and only the first 2 features. That will be X and Y is iris target. Now, I am creating a mesh, a 2D mesh of synthetic data. Now here comes an important part. Here we are defining, creating the model. svm.spc, kernel, I told you there are 3 kernels, linear, polynomial, RBF. Here I have used linear. C equal to, I have used the default C equal to 1. You know how to change it. You can do that later. But this is what I want to focus on now. The decision function shape is OVR. What is this OVR? How many models will be created? See, there are what is this? 10 raised to minus 4. Right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So 6 into 4, 24 models here. This one, gamma, 6 values are there. For each value of gamma, 4 values are here. So 24 models will be created here. Plus 4 models over here. So 28 models will be created. 28 times it will run. 28 times the SVM model will run. Out of this 28 attempts, the one having the best performance, that parameter is our best parameter. We are going to see that. So once you define the parameters, svm.svc, my decision is multi-class OVR. In grid search CV, I am specifying those parameters. I want to do 5-fold cross-validation. Then fit X train, Y train. Okay, just execute this and see what you get. You should see something like this. What's up, field? कौन सा? वो फील्ड नहीं क्या क्या क्वेश्चन है? Do you see results like this? Are you getting these results? नहीं ऐसा दिख रहा है क्या? Okay, so here look at the grid scores on the training set. It has tried RBF kernel with C equal to 1 and this gamma.